Gasoline direct injection, or GDI as it's commonly known, is the next generation of fuel injection now being used on most new executive-type production vehicles. Some manufacturers use different names for their version of a direct injection system. GDI is a direction in which all vehicle manufacturers will have to go, as GDI gives outstanding performance and fuel economy while maintaining the minimum of exhaust pollution. The GDI system has two running modes, stratified and homogeneous. Stratified charge mode. This mode is the economical combustion cycle. In some systems, the air-to-fuel ratio can be as high as 65:1. In this mode, the injector delivers a minimum amount of fuel into the combustion chamber, just before the piston reaches the top and before the plug fires. This mode is used at idle and light throttle settings when the car is driven slowly in some systems. Homogeneous running mode. This mode is what would be called a normal combustion cycle, with an air-to-fuel ratio of 25:1. In this mode, the injector delivers a normal amount of fuel into the combustion chamber. This gives the engine the required performance as the car goes faster. The engine management system determines when the system needs to switch between the stratified charge mode and the homogeneous running mode. As the fuel is injected directly into the combustion chamber, it does require components that will work at much higher pressures, up to 200 bar in most cases. This means that the cheaper produced plastic-bodied injectors and aluminium-cased fuel pumps have now been replaced by high-pressure stainless steel fuel pump and injectors, both designed to deliver very precise quantities of fuel at extremely high pressures for minute durations of time, in some cases fractions of a millisecond. This video attempts to show you some of the problems you may find with these types of injectors. In many instances, you may at first only detect a consequential problem caused as a result of the injector's performance. We hope this film will encourage you to not only detect and solve the problem, but to also identify and rectify the initial cause of the problem. These injectors are being driven with the correct peak and hold currents in sequential sequence, as they would be on the engine. Correct electronic operation of these injectors is far more important than running them at the potentially dangerous high operating pressure. To enable a safe and easy examination of the injector's performance, the Asnu system runs at a lower and safer operating pressure of approximately 5 bar. The vehicle's GDI system operates at a potentially dangerously high fuel pressure, varying up to 200 bar. With the injector opening for short microsecond durations, with a maximum opening duration of only 5 milliseconds, any visual spray analysis could be both difficult and dangerous. The Asnu allows the user to safely examine in greater detail the injector's spray pattern for any discrepancies in the fuel distribution and atomization. For ease of use, in some operating modes the Asnu system opens the injectors for a much longer duration. The injectors can be operated at various RPM and millisecond settings, restricted only by the number of injectors being tested in the sequential testing operation. The Asnu also has a single injector selection feature, and with the ability to rotate the injectors for closer inspection of the spray pattern, the technician's diagnosis can be far more accurate and critical.